So I guess it depends on how much you've been working with APIs and stuff, but JSON is used in almost every REST API out there. And to a lot of times when we go get JSON or are pushing JSON, we're going to use the HTTP commands to do that. So we're going to start with today, we're going to start with just kind of going over the HTTP download and upload commands and kind of the properties of them, how they're formatted, the syntax in Lua. And then we're going to go through some examples here and just kind of going over how the get command works or up or download. And then we're going to interact with some JSON data. We're going to parse it out and do some fun things with that here in the middle. And then later on, we'll work with a REST API and controlling a device here that I have on my network called a Falcon Player. So we're going to do some lighting controlled stuff with that. So let's start off here. We will open up our download toolbox here. So what I have here is, let me get this out here so you can see what we're working with. So this is kind of your basic syntax structure of the HTTP client download. So the HTTP client library here, I don't know if any of you know this, but within Lua, if you click on the HTTP client and hit the help button, it opens on a page you can't see. We will open this up here. You have all of this information here for you. So you can go through download, you can see an example, we can go through upload, see an example. We have all of this inside of our designer here already for you, so we can kind of quickly go through this here. So first part of it is our client command, and then either download or upload is what we're going to be working with today. When we call the download command, we have basically a table that's built, as you can see here, or an array within this grouping. And then we have a whole bunch of entries inside of that table. Our first one is going to be URL, which is the where we're going to be getting the information from. And the spelling, just like everywhere else in Lua, is very important. So if you capitalize URL, this will not work. So make sure that you do have your syntax correct within here. So URL and then just wherever we're connecting to. So whether this be a website, whether this be an IP address that we're talking to, anything like that that HTTP is required for, this is where you'll start here. The next section here is going to be a entry called headers, and it is also a table. So you can see here, within here, I just have a single entry. Even with that single entry, I'm still encapsulating this within a table. So make sure you do not forget that part. The other thing to remember is because this is an array or a table, we do have entries, and these commas are very important. If you forget one of these, you are going to have errors show up. And so make sure when you are creating your entries within your table, you do have those commas separating each one of those out. Headers is always a fun one. This is probably going to be the biggest pain for you, is trying to figure out exactly what headers to use and how the device that you're talking to wants to receive these headers. Most of the time in a documented API, this will be called out for you. I would say half of the time. The other half of the time, you're going to have to do some snooping and stuff like that. A nice tool to use for this is an application called Postman. And basically, Postman is, I describe it as Wireshark for REST APIs or APIs. And so you can open this up, you can test out all of your code in there. You can see exactly how all the formatting is needed to be done. And there is a section in there that kind of pre-populates some headers for you and sends them all out. It's kind of a catch-all. You can actually just easily go in and check mark the ones you want to use or don't want and test your commands. And you can see the information come back or the control work or whatever you're looking for. And then once you have that kind of established, now you know what headers you need to use and you can include them here in this table. Just to be clear though, this obviously has a single entry here. If I want to add another header, I do need to add the comma at the end so that I can start a new field here, whether it be accept or whatever we're going to use. Make sure that you do add that comma in there to create another entry within your headers table. The timeout feature or function is going to be the amount of seconds that we are going to wait for this to complete. If we wait over 30 seconds, we're just going to return an error and say, hey, it took too long to get our information back. So that is the property there. And then the event handler is once this is complete, what are we going to call? What we're going to call here is done, which will then loop back up to here. As you can see here, this is called this function done. So this can be called whatever you want, this can be called complete as long as this right here is also called, if I spelled that right. So once this function up here is called, we are going to return some parameters here. So the first thing we're going to get back is a table of all the information. You will get a whole bunch of information in this table. The next entry is going to be our code that comes back. So this is our success or error code. So in HTTP, a code of 200, which we will get to in the upload section, that is a success command. Most of you are probably familiar with HTTP error code 404, not found. There's a whole list of them. And so we can use Postman or Lua to troubleshoot this and see which codes we're getting back and what we want to maybe do with those codes. But there is a whole list out on the web of those HTTP codes. Next part is the actual data that we're going to get back from it. So when we send this download command to google.com, it's going to go out and it's going to download the website. And so all of that data will be encapsulated in this variable called data right here. If there are any errors, they will come back here through the error variable. And then the last part is going to be a table of headers. So it's going to return a whole bunch of, just like we are sending headers out to it, once it sends information back to us, it will also include headers. Next part down here is going to be, we are going to print this information out in a readable format. And we are going to run through an example of this. So I'm just kind of going through the syntax now. We will go into an example and actually complete this information. We are going to print and we're going to format this string in a way right here. So we're going to print this statement out right here. So we're going to say HTTP response from, and then this entry here is a string and it references the first entry over here. So table.url. So we're calling this table and we're pulling the URL out of it. That is going to be a string. And so we are going to print the URL that comes back. We are going to return or print the return code, which is either our success or error code here. And then any errors that are coming in, we will print those as well. If you see over here, we are printing the error, but we're also evaluating error here as well. So if error exists, we are going to print it. If error doesn't exist, we are going to print none. So we do have some kind of evaluation here. Obviously, if there's no error, we don't want to print a blank field. So what we're going to do is we're going to actually go down here and print none. Our next section down here that's commented out for us right now is the header section. So most of the time, I really, depends on what we're doing with the data. I probably don't need the headers information. One thing I could do is just leave headers off here if I wanted to, so that it would return that information. But the other thing down here is we can actually go through and parse that table. And so what we see here is we're going to print headers. And then what we're also going to do is we're going to run an pairs loop on the headers table. And we're going to return the name and the value of that. And we're going to print that whole table out for us. So same thing that we did up here, we're doing again down here. And we're going to print all the names and the values all the way down. And then the last thing we're doing here is we are going to print we're going to indent the line first, and then we're going to print HTML data, and then we're going to print off all of this data. So as you can imagine, we will run this one here in a little bit. As you can imagine, grabbing all the data from google.com is going to return a large amount of data, but we will be able to print that off and see exactly what's going on. So let's go ahead and we'll jump over to our upload command here. All right. So now let's talk about upload. So this is where we're going to take a specific chunk of data and we're going to send it to a specific place. So by calling out the HTTP client.upload command here, as you can see, we have similar properties. Some of them are a little bit different. First one is going to be our URL. So where are we talking to? And now in the upload section, we're going to have a couple new pieces of information here. So the first one's going to be method. And so this is how the device that we're talking to wants to accept this information. So I would say the most common is post. So post command is going to post the information out. Some device or some services or devices or whatever you're talking to support post or put. This post test server that we're going to talk to later does not support put, so we will use post. It's kind of a trial and error thing, or it might be documented within their API. But within within Postman, sorry, I drew a blank there. You can change this method from post to put and test that out in there first before you go through and do your try or do your testing within Lua. Next section here is going to be the username that you're talking to. So if the device you're talking to requires authentication, your URL would have an HTTPS inside of it. And then down here, you will have username and password for talking to that specific device. Data is going to be the actual data that we're sending it. So right now, if we have this, this is obviously a blank string. But if I just wanted to send it a string, we could put this is a test in there. You could put a variable in here. There's a lot of options for what we're actually going to be sending out to this device. Later on, we will encapsulate some data in here and we will actually send it off using some JSON encoding. So we can do something with data and then we can actually populate it into this field to be sent out. The header section is similar to our download command, but here these are specific examples of kind of how we're formatting the information we're sending out. And so we can include any type of headers that we need to. Like I said before, this is kind of up in the air depending on your API or the site you're talking to, different headers will be required. And then same as download, at the bottom here, we do have, again, an event handler. So once this is complete, we are going to call done. Done then loops back up here to this function. It is very important that this function, just like any function within Lua, is above where it's defined at. So we need to define the function first before we can call it. So if this chunk of code right here, 3 through 5, ended down here and we called done, once this was complete, it tried to call done, it will return an error because it doesn't know what done is because done is defined below our upload command. So similar to our download command here, we return a table of all of our information. We get an error or a success code back. We get any data that it wants to send back to us, whether it's saying, hey, complete, or it's responding with a status or whatever we're doing here. And then any errors that are accounted for or sent back. Just a note that these 4 pieces of information right here are standard coming back from there. But if I do not need the errors, I could just leave it off. If I don't need the code, I can't just leave that off because the first thing that gets returned is the table. So whether I define it as table or variable A, I still need that to be there in order to kind of get to the piece of information. So if I need the 4th one, I have to define A, B, and C before I can get to D. And then similarly here to our download function, we're just going to format our string here in a way where we have a response code with our code. We're going to print any errors and then any data that's coming back, and it will print in our debug window. What you see here, we do down here have a control called post, and we are just saying anytime that that button changes states, we are going to call our upload command here. All right, let's get into some actual functional piece here. So first thing we're going to do is I'm going to start here. This file will be sent out to you in a follow-up email here with the recording. So you will have all this that you can do testing on. Just so you know, so everything here on the left is what we're going to complete today. Everything over here on the right is a completed file for you already. So you can actually, if you get stuck while you're trying this out, you can get in here and actually work with this. Everything you will be able to do the first two sections on your own. The section 3 and section 5 are interacting with a Falcon Player that I have with me here. It's very, very simple. It's just running on a Raspberry Pi. So if something that you want to work with and practice with APIs, if you have a Raspberry Pi, you can install the operating system for Falcon Player on there and interact with it. It's a very easy API to test with and kind of get familiar with and comfortable with. So that'd be something pretty easy. If anyone wants instructions, stuff like that, I can also I can provide some documentation for you on exactly how to get that up and running if you should want to do that. All right, so let's go into our get command and let's open this up here. All right, so we are going to build a basic download or get command here from a website. So first thing I want to point out is we do have a button here on our text controller, which is a trigger button, which is labeled as download. So we are going to use this button to then pull this information back. So first thing we're going to do is we are going to write our call function. So I'm going ahead and got this here. So I'm going to comment this here. So first thing I'm going to do is I'm going to define my function. So I'm going to do function download. And then I'm going to end my statement. If you're not doing what I just did when you're writing Lua, I would highly, highly recommend it. You will get stuck somewhere and can't figure out what function or call statement you haven't ended. So I'd highly recommend you go through and end your statements right away after you complete them. First thing I'm going to do is I'm going to add a print statement in here, and I am going to put in downloading. So now when this is called, I'm going to print to my debug window that I'm downloading. And then we're going to start with our HTTP client command. So once I start in and do our HTTP client, once I hit my dot here, I can see that I have a download command. So we're going to use the download command, and then we are going to build our table. So if I create my table, here's my first entry within my table. And if you remember from before, our first entry that we want to put in here is our URL. And we are going to go out and download the website, our Q-SYS website. So I'm going to do HTTP www.qsys.com. So now that I have my URL in here, I'm going to add my comma here so that I can put my next entry. And my next entry is going to be my headers. So, and this is also a table. So I'm going to indent that like that. Now I can keep this as one line if that's easier for you to look at. It really doesn't matter. So I can have something like this. And we can just create this because it is just a single entry in here. I'm just going to create it this way. So the only headers that I need within my file here are my content type. So if I do content type, just like this, and the content type is going to be because we're downloading our web page. Our next section that we need to add in here is our timeout. So we're just going to tell it if we don't get anything after 30 seconds, we will just abort. And then our last thing that we need to add is our event handler. So and that will be equal to done. So now we have our actual download function. Let's go ahead and come up here and let's define done. So we need to above here. So this will be our response. Whoa. All right. Now let's define done. So let's do function done. And then this is where we need to return our information. So our first one is going to be a table of all of our information. Next one's going to be our code. Next part is going to be any data that it's sending back. Last one's going to be, or next entry is going to be any errors that we receive. And then the last part is going to be a table of headers. Let's end this here. And now let's print out that information that we're getting back. So let's do a print statement. And then we are going to format a string. So the string dot format. And then let's make this into a readable string that we can actually see information from. So we're going to say HTTP response from. Then our first character within here is going to be our string. That's going to be our URL that we're getting back. And then our next entry that we will get is, let's do our return code. So to be, and our return code is going to be the integer that comes in right here. So let's set that equal to an integer. So to integer just like that. And then our last piece of information that we're going to print out is our errors. So we can just do error like this. And then we will do our %S. So now we have the basic format of our string. And now we need to include all of the pieces of information that are going to get populated into this string, this integer, and this string. So our first one, we're going to look through this table. We're going to grab the URL out of it. So we'll say table.url. Our next one is going to be our error code that comes back. So that's going to be this integer right here. So we'll use our variable code that's getting passed in. And then last one is we want to print any errors, or if no errors exist, we are just simply going to print none. So now if we were to run this, we would get all this information out printed nicely here at the bottom. You will notice that I didn't purposely print data in here yet. That data is going to be a large chunk of information when you download an entire web page. So we are going to format that differently down here at the bottom. Next section we're going to do is we are going to print our headers. So I'm just going to simply do headers just like this. So what this will do is just print a single line with headers on it. And now, because headers comes in as a table, we need to run a pairs loop on that so that we can parse all that information out. If I were to just print headers, it would just show table with its memory ID in the debug window, so we wouldn't actually see any information that's inside of it. So we are going to go through here and write our pairs loop here. So if I do 4, and then these next two entries are basically variables. I'm going to use the header name and then the value, but you can use any variable name that you would like. And then we're going to say in pairs. And then we are going to run this on our headers table. And then syntax for that is going to be do. And I started this. I'll make sure I come down here and end it. And now we need to go through and parse our information out. So what I want to do is I want to print all of this. So I'm going to start with our print function. And then I'm going to format it. So I'm going to do string.format. And the format of what we're going to be doing is we're actually going to take the name and the value and put them next to each other. So I'm going to space this out just a little bit. So let's do.
Hey, Tyler.
Yeah.
Just poking in, we have a couple questions in there. John wants to know about the error code 200, and Pat wants to know how we know that headers is a table. I've been typing in answers live, but that seems like one that you might want to address. Just
So
FYI, that event handler, for those of you who are confused, that event handler what the return values that you're going to get for that might be slightly different depending on how it goes through. So if you're getting that return code error of 200, so that's where you would see it, would be that code would be where it's equal to 200. If there's no error, that error is going to be null.
yeah. So in the 200 is just a known. So we could look up the HTTP codes and it would spit out 200 is good, 404 is not found. There's a whole list of them out on the web. So there are obviously some devices that you're talking to will return different values. Like I've seen, like when you talk to Teams adaptive cards, if you send a good chunk of information, you're actually going to get a 202 code, meaning that it succeeded. So it really depends on the device that you're talking to and what that code is. And then the way that we're able to grab this information in our function or return function is right here. So table code data error headers. That is a standard return of information. So if error does not exist, like Hope said, it will be a nil value, which is why we can use this this evaluation here. So if it's nil, then I can just say none. Or if it actually has an error, I can actually print out that error, or this will return the error here.
Yep. And for those of you following along at home, I did link a mozilla.org document with a list of all the status codes and an answer to someone's question. So you can look those up to see what they are.
Was there one more question, Hope?
The other one was how you know that headers is a table.
Oh, gotcha. Okay. So there's two ways to know that headers is a table. We could just run this function and we could print headers and it would come back as a table. The other way I know this is within the help guide will state this. Let's see if I can find right here. So arguments headers as a table. So it is telling us right here that headers is a table. That will be returned no matter what you're talking to. Headers is always going to be a table of information. All right, so we have our string.format here. So we know that our first entry is going to be our name. So we're going to say h name, and then we're going to do our value. So what this will do now is every time it runs through this and a new entry is found inside of headers, it will come down and print, and it will do it'll say the name is equal to the value, and it will run through and print all of that for us. And then the last thing we need to do is we need to come in here and we need to print our big, massive chunk of data. So we're going to return a line, and we're going to say HTML data. And let's add a space in there. And then what we're going to do is so we're printing HTML data. And then by adding our two dots here, we're going to concatenate, or we're going to attach on a piece of information. And we're going to come up here and grab our data chunk, and we're going to print that down here with it. Data is already a string, so I don't need to encapsulate it in here, or I don't need to say dot string. It's already a string. And so we're going to print HTML data and then concatenate on our big chunk of data to the end of it. And then our last thing we need to do is we need to write our event handler. So when we press that button, we want something to happen. So we're going to access controls, which is our group of controls inside of our text controller. And then I'm going to say dot download. So now I know that I'm referring to that button, and I want to know when it changes states. Because it's a trigger button, I'm just going to call out its event handler. If this was a momentary or a toggle, I would have to further define if it's true or false. But because it's a trigger button, all a trigger button does is fire an event handler inside of Lua. And so I can just say this is equal to download. And I don't need to call the function. I just need to call the variable. So let's go ahead and let's emulate this and see if I mistyped anything. Miracles do happen. All right, so we have our chunk of code here. So if we come out here and we press our download button, you'll see once we come in here, our first thing, let's try to get you lined up here so you can see. All right, so our first thing that we got back here was, well, first thing that was printed was downloading, because we ran this download function. So we see downloading. Our next thing that's coming in is our HTTP response. So it's from the string, and it returned it from Q-SYS.com. Our next one was our return code, which was a success of 200. We didn't have an error, so we printed none. And then we ran through our pairs loop here on the table of headers, and you can see all of the different tables that it printed out. Now, if I just printed headers, you would see something like this. So this is how a table is printed out if you do not run a pairs loop on it. What this is identifying is the memory location at which it's stored. This doesn't mean anything to us. Obviously, we can't read that. And so we do need to run a loop on that to see. So we could run now, what we could do is run another loop on alt service, and we could see what's inside that table. Same thing with server content type. You can see all these different tables that it returns inside of a table. So you can get pretty deep as far as having to jump from table to table to table, all the way down till you get the piece of information that you're wanting. So this is our group of headers here. And then our last thing we're printing out is our data. And let's expand this so you can see all of this that came back. So this is the entire Q-SYS webpage. As you can see, my scroll bar here, it's a lot of information. Highly recommend you don't try to return a whole entire web page. It's going to be very hard to parse all of that data out. Most of the time, you're going to be talking to a device that's going to return either a table or a chunk of information that's usable. Most of the time, we're not going to go in and try to print out entire web pages. All right, so let's jump and let's work with something that's actually usable. So what we're going to do now is we're going to jump into our JSON data. And what our goal is here is we have a chunk of information that we're going to go out and grab. We have a JSON table that's living on a AWS site that we're going to go pull down. and we're going to parse all the information out of it. So if we open this up, you will see here that we have some controls already created for you. So we have a list box of core models. We have some text boxes for how many I/O channels, AEC channels, VoIP instances, and USB I/O bridge. So if I go ahead and open this up, you'll see that we have some information in here. So let me kind of go over here what we have already wrote for you. So the starting here is we are going to use the rapid JSON library. There are two types of JSON libraries within Lua. The first one is just standard JSON. It cannot handle large amounts of data. It will run memory errors eventually as you start using just standard JSON. So that's why the rapid JSON library exists. We can use this to parse through, encode, and decode large amounts of data very quickly into Lua tables. Just so we're all clear, JSON, which is JavaScript object notation, is a string by default. So what this allows us to do is it allows us to take a massive chunk of data, which would normally be a table in Lua, and we can convert it to a string that can then get sent out as a data packet. So I cannot by default just send a Lua table out as data to a specific site or receive that in that same fashion. So by using JSON, it is a string, so I can pull it in, I can decode or encode that table, and then I can get information back out of it again. So what we are going to do today is we are going to use this URL right here, and we're going to go grab this chunk of information. So first thing we can do is we take this link and we go out here and we just post that. You can see over here, we've now downloaded that JSON table. So if I open this up here, you'll be able to see what's inside of it. And so I'm using VS Code to view this. You can use whatever IDE you want to use. I like VS Code a lot for doing JSON information. There is a cool little trick. If you use the extensions in VS Code over here, there's an extension called JSON crack. So actually, if you do this, we can actually find the path to getting this exact information out of it. This table is obviously very simple, but if over here, this JSON crack visualization, this shows you exactly how this table is built. So this is super helpful when you get into really layered JSON tables or JSON strings or Lua tables in order to get all of the information we want back out of here. So this is the chunk of data for each of the cores that we have listed here. And we're going to go through and parse this information out and pop it into our table so that we can click on a core and we can show all the 4 data types here at the bottom. So let's get our JSON file open here.
Hey, Tyler, while you're opening up that file, we had a question from Sean. I typed an answer, but I figure might be helpful for people. He said, would you ever want to use JSON over rapid JSON? Better to always use rapid JSON. And I would say the default one is fine if your strings are going to be very small and you're just doing basic parsing. But one of the first things I do when I create a script template, if I know I'm going to be using JSON, is I just require it.
Yes.
Rapid JSON also has some methods that are not supported by the default JSON. So you're going to have to use it for certain applications of more complicated parsing.
Yep. All right. So, So first thing we've done here is we've added our, we've defined our rapid JSON library here. So first thing we want to do is we want to define our tables that we will be taking our information and putting it into. So our first one is going to be our cores table. And the way that we can build a table or an array in Lua is we just define it as an empty table. So this is just going to be a storage location that once we go and parse this information out, we can populate it into our table here. The next one is we want to have a list of all the information here. So let's build one more table. And so we have kind of a blank table here now that we can also store information in. So I guess our first task, I guess, is we need to go out and we need to grab that information and we want to do something with it. So we're going to use our HTTP GET command. Or our download command. So let's define our function. So I'll do download function. We're going to end it here. And our first thing is we're going to call our HTTP client. So let's do HTTP client download. And then let's build out our table. So first entry is going to be URL. And we already have defined our URL up here as a variable. So we can just call out our variable of URL. Notice that this is case sensitive. So URL here versus URL here are two different things. So we're telling the client what URL we're going to, and the URL just happens to be named variable URL here. Our next section here is going to be our headers. And this is also a table. This one's going to have a couple different entries in here, so I'm going to use a couple different lines. So first one's going to be content type. We're going to set that equal to and then our next one is going to be what we're going to accept. Everything. And oops. Oh, come on. There we go. All right. So there we go. So we have our two entries here. I like to add a comma at the end of it. So in case I need to add a new one later on, I can always do that without having to remember, oops, I forgot to put that comma up there. So our headers table is complete. Next one's going to be our timeout. And we'll just do standard 30 seconds. And then our event handler that's going to get called will be done. So now we have all of this is complete. Now we need to come up here and we need to define our return data. So if we come up here, let's define our function of done. End it. And just like we had before, we have all of our variables here. So it's going to be table, code, data, any errors, and our headers. So first thing we want to do is we want to print our function out. So let's go ahead and print format. And then let's go ahead and I'm just going to come up here and copy this because we've already done it once. And why recreate the wheel? So let's come grab this. It's time there. There is our information there. So we already know what we're going to be grabbing because we've seen that in our VS Code here. So the first thing we need to do is we need to store that data that we got back into our table. So we are going to set our table equal to, and because it comes in as JSON, we need to decode it. So we're going to say JSON.decode, and what we are decoding is the data we get back. So what we've just done is we've taken that JSON string and we've decoded into a Lua table. And now we can actually go in and access the table and get parts of information out of it really, really quickly. So first thing we want to do is we're going to run our pairs loop on here. So for index and control, iPairs. So we're going to use iPairs this time because it is so iterative pairs is what iPair stands for, and because it will be first entry, second entry, third entry. The last time when we ran headers, we ran a pairs loop because we wanted to print out the actual name. So what that one was a key value table. So the key was I think it was like accept and all the different headers names that we're printing out. And then the value to each one of those was all of its information that we set it equal to. Here, we're just going to go through and say, hey, the first, second, third entry, because they match all the way through our JSON table. We don't need to evaluate the key each time. We can just iterate through there 1 through 5. So what we're going to run this on is our cores. So we have our cores table, and we want to know the core name. So we're going to run through the table, and we're going to take core table dot core. And so every time a new core is listed in there, and we are going to do something here. So once we run through this iPairs loop, we are going to then, once we get to a new core, we're going to take that name and we're going to insert it into our table called cores list. So we can use the command table.insert. And where we are inserting them to is our core list. And then our what we're pulling out of there is, if we go into here, CTL is the name of the core. So if we go back to our Lua table here, you can see we want to grab the name. So we are going to use the syntax of control here. So we're going to do CTL, and then we want to pull out the name. So what this has done now is it's built a table of all the different names for each of the cores that get populated out. And then our last thing we want to do is we want to take all of that information and we want to pop it into our list box right here. So if I go back here, let's call out, so controls dot, and this is going to be core model. And the way we access all the entries within there is going to be choices. So dot choices, and then now we can just set this equal to our table called core list. So we've got our information back. We've done some parsing of it from a core list perspective. And now all we have to do is, when we start this, we just need to call our download function. So we're going to call download. Once I save this, get error, where 55. Oh, probably should set this equal to. There we go. So now, oops. Let's rerun this so you can see that. So you can see we got a response from here. Everything was good. There were no errors. And now if we jump back over here, here is all the lists of the core models that came through. So now that we have all of that, now we can come down here and actually parse the information out pretty quickly. So let's go and let's grab our controls. So we want to know when someone presses one of those new cores on there. So we can do controls.core model. And when a change happens, that is our event handler. So let's go define function. Let's pass in our control from our event handler into our function here. And now let's go through and evaluate when the name changes. So we're going to say if, and then, actually, hold on. We need to run a loop. So let's do for, so we'll use I, so integer, b, our value, and let's run our I pairs loop. And this time what we're going to run our I pairs loop on is we're going to run it on our cores table right here that we built. So we're going to run it right here again on cores.core. So run cores.core. We're going to do that. So now what we want to do is we want to look for our name within there. So if we want to look for the dot name, which is our entry from our JSON table from before. And so what we can do is we can say if the dot name is equal to, so two equal signs is a comparator. And what we want to know is if this core model name matches this name, then we want to grab all the rest of the information out of there. So what we're going to say v.name is equal to ctl dot string, because ctl is this control right here. Then we want to do something with that. So let's end it. Now, if we go through here, let's go through and set all of our controls so that all of these populate appropriately. So we're going to say controls dot network IO, and that one is a string. And now all we have to do is, because v already equals our table, our cores.core, we can just say v dot and then network. Be careful here because this is populating automatically. Network IO is the name of the controls. Network IO is the entry right here in the table, and it is case sensitive as well. So we want to make sure that we use this terminology here. So our next one that we're going to populate is number AEC. So I'm going to go ahead and copy that out of here. That way it makes it a little bit easier to type. So let's do controls dot AEC channels. That is also a string because it is a text box. And this will be v dot, what we copied out of our file here. So this is the cores.core, and then we got into, so it's cores.core.number AEC. So we're jumping through the table to get to number AEC here. Now we have two more controls that we need to populate. So our next one's going to be the number of VoIP instances. This one's also a string value. And now I'm going to show you a different way that we can actually access this specific chunk of information inside of the JSON table. So we were using the shorthand of V here to get to cores.core. We can actually, we can list it out the same way here. So we can say cores.core. And what we can do is we can tell it which entry inside of cores.core we want. Well, when we run through this, we know if it's the first, second, third, fourth entry, because core model and this one are going to match. So we can actually use the integer I to know which entry within that table we're getting to. So if we use I, what that has now done is, if it's the, let's say it is, let's say it's the core nano, I will be equal to 2 because this is 1, 2. So now all we have to do is, once we get back into here, all we have to do now is say dot, and then like here we did number AEC, our VoIP instances is number VoIP. So we've got into there, you come here, dot number VoIP, just like that. So we can access it this way. Obviously this is a lot more typing, but I just wanted you to be aware that there is a way to kind of jump through here. I do realize everyone too that it is 11 o'clock. So if you do need to jump off, feel free. There will be a recording of this that will get sent out. Um, I just want to make sure you guys understand exactly what we're talking about. So I didn't want to get too or jump over anything too quickly for you guys. Hope did someone raise their hand? I thought I saw someone raise their hand here.
Oh, I didn't see anything, but
It popped up on my screen, but then it went away.
maybe you answered their question. Oh,
Okay.
someone said, thank you, great information. So
All right.
you're doing good. You're doing good.
All right. It's just a lot of information to cover in an hour, that's for sure. All right, so last one we're going to do is controls dot, and then we want to know if that core has an IO USB or a USB IO bridge on it. So instead of string this time, because we're not returning a string, we want to return the true false value. So we're going to do its dot boolean. And let's go ahead and use our syntax that we used on the last line. So we're going to say cores.core I. And this last one is going to be, let's come back here, is going to be USB bridge. Copy that out. So should have something that looks like this. Once we get through this, I want to stop running our loop here. So I'm going to use the syntax. So I broke the loop from running, and now everything has ended. If we typed all this out right, we should now, once we click here, it's not popular. Okay, what did I miss? Oh, capitalization matters. All right, so let's make sure we have, it was looking for capital N name, and the name is lowercase, so make sure that you have things right order. Now, when we click on this, now you can see all of our information gets populated out here. So if I click on Core Nano, we get all of its information, Flex 110, 510, and our 5200. And you can see, because the 510 and 5200 do not have onboard ISB, light goes off. Once I get to one that does, I get it lit up here. Cool. All right, got a few more things here. What I'll probably do is, just because we're running over on time, I'm going to skip this post command section here. This is basically just what we would have done here is just send a sample post to a site where we can read it off. Once you get the file, you can go through and do this on your own, but there is just a site that we would be sending information to that you can see everything come back. So you can use this as a test if you're trying to make sure everything's formatted properly and all that. So you can actually use that. So let's go and let's start talking to an actual REST API device. So this Falcon Player has a very simple API. So you can see here, we are going to be talking to our host device, which is not that IP. It's actually, it's a local one here on my network. And then we do have another header of accept. This is going to be a get command or a download command. And all we have to do is use the simple API/playlist, and we can actually grab, and you can see this is just a table of playlists here that we're going to get back. So if we go through here, we have a list box here. So we're going to return our playlists that come back into our list box here. So our first step here is we already have our rapid JSON defined here. Our first thing we want to do is we want to call our functions. Let's call function. Wow, can't type today. And then let's go through and let's download our information. So we don't need a button to trigger the download. We just want to download when the script starts. So we are going to do HTTP client dot download. We know from earlier that this is a table of information. So our first thing that we are going to send out is our URL. And we know from our API documentation, if we come up here, we are going to send it to our host address, which is actually a local IP on my network, not this one. And then we're going to do /API/playlist. So if I come back here, what I can do is I'm going to do 192.168.200.238 on my network. Network API/playlist. Just like that. So now we have what we're talking to. Our next one is going to be our headers table. And go ahead and add our entries here. So our first one we saw from the last page, which was accept. That's going to be equal to this. Our accept. And then our last one is going to be, it wants the host address. So we are going to put in host. And then that IP is from above, so 100.8. Indent our table there and make sure we encapsulate our table here. And then lastly, just like we did on our other one, so timeout's going to be 30 seconds. And our event handler is going to be done. So now that we have that gets called right away on script start. So it's going to go out and download our new information. And the last part here is going to be our response function. So we already know that we called out done, so we need to define done. So it's going to be function done. And let's go and just grab it from our other script here so we don't have to waste time typing all that out. So we have function done and that. And so we went through and we printed our statement there. We can go through and let's print off our headers just so we can see them. So grab that here, so I don't have to waste time. Let's print our headers here. So we're going to print our headers. And then last thing we're going to do is let's print our data that we get back so we can see exactly what we're getting back. So we're going to print data. Data. So we've now printed off our data here. And then the last thing we have to do is we need to take our table, or we need our information that we're getting back in JSON. We need to decode it back. So let's create a variable called table playlist. And we're going to set that equal to JSON.decode. And what we're going to do is we're going to decode our data. And then last thing, just like we did in the last one, we need to set our table or our list box to our variable table playlist. So this is going to be .voices. And now we do table playlist just like this. Increment that down. Now what we've done is we pulled the information back in here and we're going to print the data so we can see it. And then we're going to decode it, and then we're going to populate it into our list box here. So if we go through here, you can see here's all of our response from our device. Here's all the different headers that it sent back to us. So you can see here, here's the allowed method. So this one supports get, post, options, delete, and put. The date, the server type, content type, all the different stuff. And then here's our table of data. So here's data, cloud lights, running lights, spotlights. So this is returned as a string. So we need to convert it into a Lua table. So that way we can use it to populate our box. Now, if we come over here, you can see now we have the 3 playlists that exist on the device. So if I go to the device and we go to let's go to our playlist. You can see here's our 3 playlists: cloud lights, running lights, and spotlights. You'll notice that these 3 match accordingly right here. Right, so now we have our last thing here is now what we want to do is we want to be able to choose one of these. So this is just a copy, just so you know, of what we're doing is we're taking the playlist and we're sending it down to this new text controller here. So that way they match each other. And now we should be able to hit cloud lights and hit what we want to do is be able to play and stop this playlist inside of this player. And I will bring up the web page for us to view this. So let's go and let's look at our API commands here. So we can notice here that we have a few different information here. So our command structure now is API command and then colon command name and the arguments in which that we need. So arguments names would be name, and then we have the name of the playlist if we want to repeat it, and if not, running here. So we have start playlist and then the 3 commands, and then we want to stop the playlist, and we don't need any extra commands with this because we just want to simply stop it. So what we'll do is we'll write this code over in our here. You'll notice here when we choose different ones here, that's going to update the playlist that we send out to our command. So we already have that information populated in a text box for us. So let's go here and let's open up our script. This one, because we're going to be sending information to somewhere, what we want to do is we want to use our upload command. So let's go ahead and define our upload command. So let's do function, call it post data. Let's end it here. These out. Let's go ahead. Let's go ahead and start writing our command. So first thing we want to do is call out our HTTP library. So HTTP client.upload. And just like the other one, just like download, this is also a table. The first one is going to be our URL that we're going to be sending out. And now we want to format it just like we have it in our API here. So that one here. So it's going to be API/command. So if we come over to here, this is going to be our web address that we talked to earlier. So 192.168 API/command, just like that. And then our method of posting this. Our method of posting this is going to be post here. And now we want to send out our data. And the data is we are going to do some JSON encoding. So let's just set this equal to the variable JSON data. And then the last part here is our headers. So let's define headers. And that one is also a table. First entry from our last page here is going to be content type, station, JSON, Next entry is going to be content length. And this one will be the length we want to know is basically we want to tell how long the data we're sending it. So the easy way that we can actually do this is we can use the pound sign here, and we can actually encapsulate JSON data. So what this will do is this will return an integer value of how long JSON data is in bytes. And so we can actually send it out as a number. So this will return this pound JSON data will actually return an integer value that we can send out with the under the content type header. And then our last one, just like before, is our host, and that's going to be our IP address of our player. So that's going to be that IP there. And then our headers table is complete. Then the last thing we need to do is we need to call our event handler. So event handler equals done. So then, just like from before, get this commands. We're just going to return our table of information here. So if we want to just grab this guy, we don't have to write this over again. So this one's just going to return table code, our data and errors. We don't care about the headers, so we can just get rid of that. Go ahead and end that function. So this is going to print off exactly what we get back. And now we just need to write our JSON data. So let's go ahead and let's come down here and let's create our JSON data. So our first thing that we want to know is we want to write a big function for when the play button is pushed. So we're going to do controls dot play dot event handler. And that's going to be function. Go ahead and end that. And now let's create a local variable, and we'll do table command. And then let's create a table out of this. So we're going to do a local table called table command, and we're going to build our table. So our command is going to be equal to start playlist, just like, so all of this is coming, just so we're on the same page, is we come back to our API documentation, our command, we're building this table right here now. So our command is going to be start playlist. Our argument will be the name of our playlist and then false and false. So we already know the command is going to be start playlist automatically. Our next entry in our table is going to be our arguments, and that is also encapsulated in a table. So I'm going to have an argument table just like this. Our first entry is our playlist name. Well, we know that we have a control for that already on our text controller. It's going to be our playlist, and we're going to grab the string out of that. And then if you remember from the API we just looked at, the next two entries are just false and false. So what we've done here is we've created our local table called table command, and we've encapsulated all the information in there. Now what we can do is we can print, so we can see exactly what we created. So let's do print, and let's do JSON.encode. And let's encode that data into a JSON format. And all we have to do is reference our variable called table command, just like this. And now the last thing that we can do here is we just need to post that data. So what we can do here is we're going to come up to our post data. Oops, I did mess one thing up. We need to pass this in. So what we can do is we can pass information in through our variable name here of JSON data, and we're going to pass that data down here. So if we come back to here, all we have to do is now we just call post data, and it's telling me that I need some JSON data. And so what I want to send it is this right here. So I'm going to say JSON data is our encoded table. That's going to get sent out to our device. Now I know we have one more control, so let's go ahead and let's make this easy on us. Let's go controls. This is going to be our stop command. Now this one is a little bit different from our API here. So this one's just the command is stop now, and then we need an empty table for our arguments. So stop now. Okay. So go here. This is stop now, just like that. And then I need my table to be empty. Go ahead and now we just have our empty table arguments. Just make sure I need. Okay, so there's my local table. Now I can do the same exact thing here again. So I can print my table out, and then I can post my data to here. So let's see. Everything looks happy. So let me go. Let's get this set up right next to it here so we can see both of them at the same time. So now if I hit cloud lights and hit play, there it goes. Now it's playing. I stop it, stops it. Now let's go to spotlights and hit play. There's spotlights, it's playing. And if I stop it, it stops. And do the last one here. So running lights is playing. Stop it, it stops. So, and then you can see here, oops, this one, you can see here. So here's the command that's getting built every time we hit one of those. So there's cloud lights, there's spotlights, there's stop now in our arguments table, and then exactly what's happening each time. All right. Well, I think I got through it. Obviously, quite a bit over here, but hopefully that was good information for you guys. I will stick around here. I don't know if there's any hope. Is there any questions out there that we need to run through?
We have one open question about the difference between .download and .get.
Let me.
We have a question from Nick, who a few people asked about download and .get, and I think I probably muddied the waters a little bit with my explanation wasn't 100% perfect. But just to answer the first part of Nick's question, he asked if .upload is a wrapper method to encapsulate any of the standard HTTP methods for transmitting data, and that is correct. That's why one of the parameters of that function or method is to actually say what the method is. But maybe you can explain the difference between download and get better than I can.
Well, let's use the help guide because that's what I always use. I'll be honest, I don't know 100%, and it's kind of it's a hard one to kind of differentiate. Let's just read through it here and see if we can come up with an answer together. Retrieves data from your table. Get request method.
I mean, my general thing that I was saying is
Yeah.
that you definitely need to read the API documentation before you decide which method to use, because like Tyler and I were talking about before this started, some manufacturers will have you use a get in order to send commands because that's what they decided to use. So you really, it's follow the documentation. My understanding of download is basically it's you're pulling data down. So it would be used if you're pulling in the information from a web page or if you're pulling down a file. But um
Yeah, I'll be honest, I have never used .get. I use .download and .upload every single time. Obviously, there will be cases where you will use .get, and just like Hope said, it's really going to be depending on your API. Because using .download will work. You know, I had an API I was working with yesterday, with or this morning, I guess, and it needed a get command. Um, for that, but I use .download to pull that info or to get, which is this is what Hope was talking about. Like we were controlling the device with a get command, which in my opinion makes no sense at all. Like obviously I should upload information to a device to make it do something, but in this case it needed a get command sent to it with a specific URL with the command inside of it in order for the functionality to be achieved.
yeah. So the help
So
file says that download is for downloading data. And what I'm going to do is I'm going to find out what it does under the hood, and if it's helpful information, maybe we get that added to the help file.
yeah.
I don't see any other questions. Thank you all for sticking with us. I know we went a little long, but I think it was worth it. We got to learn a bunch of fun new things. I found this very helpful. Thank you, Tyler.
Yeah.
My last little plug before this is if you saw this and you were like, this is cool, I want to play with it a little more, I need some information, you will get the file from today. And if you go and you search our webinars, you can actually look for a previous version of this webinar, and there's a file there as well if you just can't wait to get your hands on it. And then my other plug is just follow me on communities. I've posted some stuff about this. We have this great new utility plugin called Command Send and Receive, and you can use it for HTTP commands. So if you want to use scripting for parsing the data, but you don't want to manage that connection, you can actually just use that Command Send and Receive utility, and it will manage all of that for you. So check that out. And I have a starter file for that is linked from communities. It's on GitHub, and it goes through all of that. And there's a fun little challenge at the end, and you get to make things that are funny. So check that one out. It also shows a little bit about parsing JSON data. So that's my plug.
Awesome.
And
Yeah. Thank you, everyone. Just so the device that we worked with at the end was a Raspberry Pi with Falcon Player put on it. That is something that, if you're familiar with Kevin Rodas, he uses all the time in his Christmas lights stuff. He will have a webinar at the end of December. I believe it's the 23rd. If you check our webinar site, we can also, I'll see if we can put a link to that in this email that goes out to that specific webinar, because that's basically what we did, but on steroids. It's just going to be massive, the scale that he does with his Christmas lights. And he will go through all of that using the Falcon Player, the API commands, everything about it that he's doing to control all his Christmas lights. So that would be definitely one to get on so that you can watch. Even if you can't join it, sign up for it so you can get the recording so you can watch it later, because it's very impressive what he's done with Q-SYS and his Christmas lighting stuff that he does every year. So
it is really cool. And if you're in Ohio, you should just go see it.
yeah, just drive over there.
Just drive over it. You loved it when you just randomly show up. I just double checked that webinar is December 23rd.
Perfect.
And
Okay.
yeah, and actually, if you want another example of some API commands, I just posted another file on communities today. It's the file that runs my smart dollhouse that there's a blog post on the Q-SYS website right now about. And I have some stuff in there for controlling Shelly plugs, like a smart outlet. So if you want to see how it works on another situation, download that file, crack it open, and have fun.
There's so many good APIs out there to play with. So I would suggest if you're ever just interested or want to learn more, just go grab some kind of random device out there and just start playing with it and try to control it. That's what I've done to get better at it. I know a lot of people have done the same things.
Yeah. There's a GitHub repo that's literally just a listing of free APIs. So you can go in there and be like, download daily cat facts, dad
Yep.
jokes.
There's a lot of
Um,
good ones on there.
yeah.
Postman has them in there too.
Yep.
If you use Postman, they have a lot of good free APIs in
Yep.
Postman that you can interact with as well. So.
I linked their Echo API documentation in the Q&A, but that's the one that I think I have a sample file for that one. But basically, if you use the Postman Echo, it'll send you exactly what you send it. It will send it back. So it's a great way if you're playing with this to see what it looks like once you formatted it.
Perfect. Awesome. Well, thanks for sticking with us, everyone. We really appreciate it. Obviously, the email will go out with this file and any documentation that we need to include in there. But reach out to Hope or I if you have any questions. I believe are our emails in there, or I'm not sure how that works with the
Just
webinar.
come and find us on
Yeah,
communities.
you can find us on communities. So yeah,
There you go. Dan, do you have any final
Dan's
thoughts?
gone. Dan's gone.
Dan's gone. Oh,
Dan had to leave, so
Dan
he's
ditched
got
us.
yeah. So
All right. Well, have a great day,
awesome.
everybody.
Thanks, everyone.